out. This will be called overdamp. So what do you want for a coil? You want a coil to quickly, when displaced, for the amplitude to quickly go to equilibrium position. So in effect, the answer is critically damped. Answer is B. So that is the answer to the question. By the way, this is time. You talk about the axis. This is time axis. This is amplitude. Okay. So we're going to go to question 5. So question 5 is about resolving forces. Okay, resolving forces in horizontal and vertical directions. So to resolve this force, you just sum all the forces in the horizontal direction. Is going to give you minus 36. The sum of the forces in the horizontal will give you minus 48. This is considering a normal axis where this is x minus x, this is minus y, and this is y. So the resultant, the summation of both forces, the resultant force is the magnitude of both forces. Okay. Plus and if you do this, you find out that you have 16 Newton, which is A. So there we go. So question 6. Question 6 talks about an electric field. An electric field, a charge in an electric field, and we want to know the work done on that charge. We want to know the work done on that charge. So we have an electric field. We have an electric field. Okay, we have an electric field. We have a voltage across the electric field. Let's call it V. We have the separation of the plates, Z. We have a positive charge that is accelerated towards the negative terminal. It's accelerated through a distance of 2x. Okay. Through a distance of 2x. Okay. What is the work done to accelerate the charge? Normally, work done is equal to force times displacement. But the force, we know that the electric field strength is force per unit charge. So the force is electric field strength times the unit times the charge times distance. We also know that electric field strength is V over G Q times displacement, which is equal to BD, the charge in this case is 3e, and the displacement is 2x. So we end up with 6v ex all over d. So the work done is 6, or you can arrange it as such, 6e v x all over d, which is, the answer is d. So the answer is D for question 6. Okay. Question 7. Question 7 is about Coulomb's force. What happens to Coulomb's force when we change the charge and the distance of separation? So from Coulomb's equation, which is Coulomb's equation all over r squared, force is directly proportional to Q1 Q2 all over r squared. So we have force 1 r1 squared all over Q1 Q2 is equal to, let's call the new force F2. The separation is increased by 3 squared, and the charge is doubled for Q1 Q2. Cancels this, cancels this. We're left with F2 is equal to 4F1 all over 9. So it's 4F all over 9, which is C. So the answer is C. Question 8. Question 8 has to do with time of flight. If you throw a ball vertically upwards, the time of flight of that ball is 2u sine theta over g. Okay. Since the ball is moving vertically upwards, so it's perpendicular to the horizontal, theta is 90. Theta is 90. We have t being equal to 2u over g, which is t. So that's it for question 8. Question 9. Question 9 is about a simple harmonic motion. So for a simple harmonic motion, the displacement is defined as such. Sinusoidal, the sinusoidal. We can get the acceleration, the velocity, the amplitude of the velocity. We can get the velocity, the acceleration, the kinetic energy, the potential energy, and the mechanical energy. That's the net energy. So x prime, which is the velocity, is the derivative of this, omega r cos omega t. X prime prime, which is the acceleration. The derivative, of course, is minus sine, of course. So it's minus omega squared r sine omega t. The amplitude of the acceleration is minus omega squared r. Of course, the ke is half mv squared. Half m, v is just x prime. Okay, squared. Pe is half kx squared, which is equal to half m omega squared So B is the answer. The reason B is increasing as K decreases. This is always a constant. Okay. So if this is decreasing, this is increasing. And vice versa. So that's what happens for a simple harmonic oscillation. Okay. You go to question 10. Question 10 talks about colors. Increasing wavelength. So we know the components of white light, right? B, right? And this direction is increasing frequency. So it's increasing frequency. And it's also increasing energy. And increasing wavelength, this is increasing wavelength. So if you want to talk about increasing wavelength, you have to start from violet, which is this. So we're looking at B and D. And the next one is blue. We don't have indigo, but we have blue. So we already eliminate B. So we have just D. So we have blue, yellow, and orange. So the right answer here is D. Okay, that's question 10. Question 11 is about radioactivity. Radioactivity. Talking about this radioactivity. Radioactivity. We have the half-life. The half-life of radioactive isotope. The half-life is 36 minutes. You need to convert this half-life to seconds. 2,160 seconds. The activity T 2.5. So the time It's equal to 2.5 hours times 60 minutes times 60 seconds. This gives you 90,000 seconds. And you can get the number of intervals by using this equation. You can get the activity. So this right here would give you a, Jesus Christ, I'm tired, man. Okay, that's it for today.